Okay, so now we're going to solve quadratic equations by completing the square. Our goals are to solve by completing the square, quite obvious, but we also want to identify key features of quadratic functions by writing the quadratic equation in vertex form, and also our vocabulary is completing the square. Okay, a little bit about completing the square. It's simply an algorithm that's used to turn any quadratic trinomial into a perfect square trinomial. Two primary purposes of the algorithm are to write the quadratic in vertex form, but also to use the square root property to quickly solve quadratic equations, but it's also used to derive the quadratic formula, which will be coming up in another video. Okay, so for example 1a, we want to find the value of c, and c is right here, that makes a perfect square trinomial, and they want us to also factor it. Now here's how we find a perfect square trinomial. The first thing, this is really important, to complete the square here, this leading coefficient has to be a 1, and later in the video I'll show you how to deal with that when it's not a 1. Okay, so bring x squared down plus 8x. So as long as that's a 1, how do we figure out the value that goes right here in place of c? Well, remember, this is the b term right here. This 8 is a b term. So we're going to take the b term, we're going to divide it by 2 and raise it to the second power, and whatever that comes out to, that's our c term. So the value of b is 8. 8 divided by 2 is going to give me 4. 4 squared is going to give me 16, so I need to put a 16 here. So I now have my perfect square trinomial. The only thing left is to factor. Now remember, perfect square trinomials factor into a binomial times itself. And the way we get these two numbers that go here is to take the square root of the first one, which is x, the square root of the last one, which is 4, and we keep the sign of this middle number, which is plus. Now the way we can tell that this is actually a perfect square trinomial is if I take the x and times it by the 4, I get 4x, and if I were to double it, I get the middle term. Okay, so it's really important to understand how to get that c term to complete the square and solve quadratic. So we have example 1b. We're asking the same question, find the value of c, which is right here, that makes a perfect square trinomial. So x squared plus 40x plus what value, and then we want to factor. Now if you think you know how to do this, go ahead and pause the video for a second and see if you can come up with the value of c. Alright, so we take the b value, which is 40, we divide by 2, and then we raise it to the second power. Okay, so 40 divided by 2 is going to give us 20, and 20 to the second power is 400, so this needs to be 400. Now put it back in factored form, because when it's in factored form, that's how we solve it. So we take the square root of the first number, which is x, the square root of this last number, which is 20, and then we keep the same sign as the middle number, which is a positive. So x plus 20 squared should give us this trinomial back again. Example 2, we're actually going to solve by completing the square now. When we go to complete the square, again, we got to remember this first term has to be a 1. The leading coefficient must be a 1. And we complete the square using only the x squared and the x terms. So this 14, we got to get that out of there. So we're going to bring the x squared down, the minus 10x, 14 equals 5. So the first thing I said we got to do is get rid of the 14. So get that out of there. So minus 14 on both sides. So x squared minus 10x. And I'm going to leave a space here because I'm going to complete the square like we did on the previous two slides. Anyway, so 5 minus 14 is going to give us negative 9. And now we want to find the value that fits here to make a perfect square trinomial. And we're going to take the middle number, which is 10. It's technically negative 10, but when we divide by 2 and square it, it will no longer be negative anyway. That's why we have a plus sign right here. So negative 10 divided by 2 is negative 5. Negative 5 squared is 25. So I'm going to add 25 to this side right here. Now the problem with this is this 25 did not exist in the problem, but I added it to the left side of the equal sign. So in order for this equation to still be valid, I have to add the same 25 to the right-hand side of the problem. So the right-hand side simplifies to 16, and the left-hand side, we are going to put it in its factored form. So the square root of the first one is x, the square root of the last one is a 5, and the sign that's in the middle is what we keep. So we have x minus 5 squared. Now we can use the square root property to solve. Just take the square root of both sides. We end up with x minus 5 equaling plus or minus, now the square root of 16 is 4. Now this plus or minus means you're actually going to solve two equations. X minus 5 equals 4. X minus 5 equals negative 4, and you're going to solve them both. So on the left hand side, when we add 5 to both sides, x equals 9. And on the right hand side, when we add 5 to both sides, x equals 1. So the two solutions are 9 and 1. Okay, for example 3, they want us to solve by completing the square again, but notice that a here does not equal 1. And a has to be, or your leading coefficient has to be a positive 1. The first thing you're going to do is still get rid of the 72. So we're going to add 72 to both sides of the problem. Bring down the simplified problem. So negative 4x squared plus 32x is equal to 72. Now we've got to deal with getting rid of this negative 4 out in front. And the way we do that is we factor a negative 4 out of both of these terms. And when we do that, we end up with an x squared minus 8x. And I'm going to leave a little space to complete the square there, and 72. So inside here is where we're completing the square. But the b value we're using is the 8 here, not the 32 in the original problem. So negative 8 divided by 2 is negative 4. We square it and we get 16. So I add 16 here. Now remember, on the right hand side we have to deal with the offset of that because that 16 did not exist originally in the problem. However, you're not going to just add 16 to the right hand side, because this negative 4 that we factored out in front, if we were to distribute it all the way through, eventually it hits this 16 and makes a negative 64. So it's as if I subtracted 64 from the left hand side, not added 16. So on the right hand side, I'm going to subtract the equivalent 64. Now I'll start simplifying. So the right hand side will give us a positive 8. The left hand side, when I factor this trinomial, it will give me x minus 4. So the square of the first one, square of the last one, and keep this sign. And then bring the negative 4 down. And now continue solving. I want to get rid of the negative 4 first. So divide both sides by negative 4. And we end up with x minus 4 squared equals negative 2. And here's where we run into a little bit of a problem. When we go to take the square root of both sides, we're taking the square root of a negative over here, and the square root of a negative does not exist. Therefore, this problem has no solution. Example 4. Write this equation in vertex form. Identify the axis of symmetry, the extrema, and zeros. Now the extrema is just the min or max, and you can see up here this is going to be a minimum because the leading coefficient is positive. Then use the key features to graph the function. I'm actually going to graph the y-intercept too because I think the y-intercept is going to fit on here because it's only in negative 5. Now you can see over here on the right hand side I have vertex form, a times x minus h squared plus k. And if you look at this middle section right here, that looks a lot like a completed square problem. And that's exactly what we're going to do, is use completing the square to put it in vertex form. Now the first thing I'm going to do is I'm going to replace the y with 0. And then I want to get rid of the constant term, the negative 5. Put the 5 on the other side. So I'm going to add 5 to both sides. And now I can complete the square. So I want to find out what value can I put here that makes a perfect square trinomial on the right hand side. So the b value is 2, divided by 2 is 1, 1 squared is 1, so I'm going to add a 1 here. But I can't forget to add a 1 on the left hand side because the 1 that's over here did not exist in the original problem, so I have to offset it over here. So I go to simplify, then I get 6 equals, and now this trinomial is a perfect square, so I'm going to put it back in its factored form. So the square root of the first one is x, the square root of the last one is 1, and I keep this sign right here, and I get x plus 1 squared is equal to 6. And now to solve, we can just use the square root property. So square root of both sides. Now I'm going to rewrite this in the opposite direction. So x plus 1 is going to equal plus or minus square root of 6. Subtract 1 from both sides. So x is going to equal negative 1 plus or minus square root of 6. Now, if we were asked for the exact answer, we would leave it like that. I'm going to go ahead and use a calculator and estimate the square root of 6. So I'll end up with x equal to -1 plus, now the square root of 6 is approximately 2.45. And then I'm also going to solve x is equal to -1 minus 2.45. Remember, when I do the square root, I get a positive and a negative. So on this left-hand side, when I combine these together, I get 1.45. And on the right-hand side, when I combine these together, I get -3.45. And there are my two solutions. I'm going to have to go graph those in a moment. Those are my zeros. Now they want us to find the extrema or maximum value. So that means I got to actually put it into vertex form. And the way we fix that vertex form is we go back to one level. We go to this level right here. Remember, we took the square root of both sides, where we're going to take that away. So we took this here, we simplified to 6. We took this and we simplified it to x plus 1 squared. Now remember, originally I put a 0 in place of y. So now what I want to do is get the 6 out of there. So subtract the 6 on both sides. X plus 1 squared minus 6. And in place of the 0 that was left over when 6 was subtracted, I'm going to replace that with a y. And now this is my vertex form right here, where this value is the h and this value right here is the k. Now the extreme values are the min or max, and remember that min or max are the y coordinates of the vertex. So since this is in vertex form, also known as hk form, the y coordinate is going to be the k value. So the minimum of this function is going to end up being the -6, which is the y coordinate of the vertex. Now we want to go ahead and graph this. Okay, so let's put the vertex in there at -1, -6, which is right here. The y-intercept was -5. And then the two zeros were -3.45. So -3.45, I'm going to estimate it to be right about here. And the positive 1.45, I'm going to estimate it to be right about there. Now my axis of symmetry is right here, so I want to reflect one more point over, so I'm going to reflect this point right here over to this side so I can draw a little bit better curve. So I'm going to now draw my curve this way, and I'm going to draw my curve this way. Alright, so our last example here is still writing it in vertex form and graphing it with the key features, but now it's going to be a maximum function instead. Also notice that the leading coefficient here is not a 1, so it complicates the problem a little bit. Now again, the first thing we're going to do is substitute the y value with 0, and then get rid of the constant term. I'm going to add the 42 to both sides. Now one thing to remember, this leading coefficient has to be a 1 before we can complete the square. So the next step would be to factor it out. So -2 comes out. I have x squared minus 10x, and then I'm going to leave a space because I want to complete the square in there. So I'm going to put a plus here, and I want to complete the square. So what c value do I have to put here to make a perfect square trinomial out of that 3 terms? So the b value is -10 divided by 2, which is -5 squared, is going to give me 25. So plus 25. But on the other side, I'm not adding 25 because there's this -2 multiplier out in front. So it looks like I added 25 here, but I really subtracted 50. Because if I distribute that -2, that becomes a -50. So I really have to minus 50 from this side. So when I simplify that all out, I'll end up with a -8 equals -2 times. Now I want to factor this right here, this trinomial, into a binomial squared because it is a perfect square trinomial. And the square root of x squared is x, and the square root of the 25 is 5. And this middle sign of negative stays with us. Now if we want to put this in vertex form, y equals, all I got to do is bring the -8 back over to this side. So -2 times x minus 5 squared plus 8. And then substitute my y back into the problem. So this is my h value, this is my k value. So that's my vertex. My vertex is actually at 5, 8. But if I want to keep solving, I go back to this problem over here, and I want to divide both sides by a -2. So this -8, when I divide by -2, will give me a 4, and that's going to equal x minus 5 squared. Now I can take the square root of both sides using the square root property, so square root of both sides. Now I'm going to use the symmetry property. I'm going to bring my x minus 5 to the left-hand side and my plus or minus 2 to the right-hand side. So this answer went this way, and this answer went that way. So I want to write my two equations. So x minus 5 is equal to a positive 2, and x minus 5 is equal to a negative 2. So x is going to equal 7, x is going to equal positive 3. So I've got my zeros here and here. I've got my y-intercept from the original problem, which is way up here at -42. I don't think I'm going to be able to put that on the graph. It's too far down. And I got my vertex. My vertex is located at 5, 8, which comes from the vertex form of the equation right here. So let's go graph it. The vertex is at 5, 8, which is right here. The zeros are 3 and 7, so 3 and 7. And as I said, this -42 for the intercept is not going to fit on the graph. So all I'm going to do is draw my curve the best I can. And there's my sketch.